Example 23. Find the x values of all points where the function has any relative extrema and find the values of any relative extremum. F prime of x gives me 3x squared plus 30x plus 75. Then I set my derivative equal to 0 to find the critical numbers so we can find out where the function's increasing and decreasing. I'm going to divide all these by 3 just to make the factoring easier. And I get x squared plus 10x plus 25 equals 0. And these are the factors of 25 that add to 10, 5 and 5. So x plus 5 times x plus 5 equals 0. If we set those equal to 0, we'll get the same thing. We get x is negative 5. So we only have one critical number this time. We'll take our critical number, we'll put it on our number line, we'll check a point to its left, minus 10, and a value to its right, like 0, and we'll check it in f prime of x. So f prime of minus 10 is 3 times minus 10 squared plus 3 times minus 10 plus 75. That's 3 times 100 minus 30 plus 75. 300 minus 30 plus 75. And again, we really don't have to go all the way. I can see that this is going to be a positive number. So it is positive on the left. That means our original function has tangent lines that are positive slope. It's going uphill. It's increasing here until we get to minus 5 where the slope is 0. So now we have to check on the other side to see if it continues to be positive or if it turns around and has a negative slope. So f prime of 0 is 3 times 0 squared plus 30 times 0 plus 75. That's a 0 plus 0 plus 75. It is still positive. So now the function turns and continues to go up because it's continuing to increase. So in the case of this function, there are no relative extrema because the function is always increasing. So in the case of this function, there are no relative extrema because it never changes from a positive, which is increasing, to a negative, which is decreasing, or from a negative decreasing to a positive. It always has a positive derivative, which means it is always increasing, and therefore no relative extrema.